All right, a cafeteria sells three different types of soda in a vending machine. The chart states the sizes, prices, and number for each size. So we have our, again, chart here, cost per soda, number sold. And question one, how much was made in the cafeteria from 12-ounce cans of soda? Well, for a 12-ounce can of soda, the cafeteria would make 75 cents. So 75 cents times how many are sold, which is 30. And 75 times 30, 22.5. 0.5 or 22.50. Selling 20-ounce bottles, that's 125 times 20, which is 25. And 24 is 150 times 25, which is 37.50. Question two, how much was made from all three sizes? So this is putting them all together. So we have 22.5 plus 25 plus 37.5. We get 50, 60, 85. That's $85. How did you use the data to find your answer? Well, first we multiplied the number sold by price for each size. And add those totals. Write a 1x3 matrix to represent the cost of soda. So 1x3 means one row by 3 columns, right? And then write a 3x1, 3 rows by 1 column, right? So 1 row, and this is the cost. So we have 0.75, 1.25, and 1.50. And a 3x1. And we have 30, 20, and 25. Describe the procedure for using your matrix or matrices that we have here in number 3 to find how much the cafeteria collected from selling all three sizes. Use the words row, column, and element. So again, remember, in the first matrix here, the 0.75, 125, and 1.50, we have 1 row, 3 columns. 0.75 is an element, 1.25 is an element, and 1.50 is an element. So how would we use these two things to try to get what we got in 2a? Well, it is just 0.75 times 30 plus 1.25 plus 1.25 times 20, and then 1.5 times 25, right? And those are added together. So we multiply each element from the row of the first matrix with the corresponding element from the column of the second. And add them together. Now you could say that different, find the sum of, right? We could use sum instead to start with, but that works there. Usually in class you would have written that definition by yourself or with a classmate, and then we would have come back together to write this one together. So this one is each element in AB, each element in AB. Remember, this is matrix A times matrix B. So this is a new matrix. Each element in this product, A times B, is the sum of the products of the elements from a row of the first or a row of matrix A and column of matrix B. Now a few things. Really here, I should say corresponding. So the first element from the row, first element of the column. And you'll note second here, from a row of A, when I say row of A, it is matrix A. Then I said column of matrix B. Technically I didn't need to write matrix there. Probably should have kept them the same just for the sake there. Then there is a example here of a generic 2x2 times another generic 2x2, and you see that you get a row of the first times column of the second. This is helpful because almost everything that we do with matrices is rows by columns, right? So when I give the dimensions, it is a 2x2, 2 rows, 2 columns. Or in the example below down here, we have 1 row, 2 columns. It's a 1x3, right? So we have rows by columns, and you'll notice this is correlating to this element. This is one thing. So we have A times E, the first element in the row from the first, times the first element in the column from the second. And then plus B times G, the second element from the first row and the second element from the first column of the second. And we add those two things together. And you'll notice that if you kind of like put those two matrices on top of each other, they would intersect at this element 1, 1 of this third matrix, this matrix that we're multiplying them together. Then the same kind of thing happens with all of these other ones. So if we wanted to find this, it is still the first row, but now it's times the second column. So A times F, B plus B times H. If we wanted this element, it is the second row, since it's in the second row, times the first column. Again, it's in the first column. And then lastly, if we wanted this one, it is here times here, C times F, D times H. Now you'll notice some similarities here. So I'm going to only do some of them, but if you look at the two elements in this row, in this column, you'll notice that they share this E and this G. The same thing happens over here. They're both being multiplied by F. They're both being multiplied by H. All right, so let's take a look at our matrices that we have here. So we have 0.75, the first element in our row, times the first element of the column. So we have 0.75 times 30 plus the second element in the row times the second element in the column, 1.25 times 20 plus the third element of the row times the third element of the column, 1.5 times 25. And what is this? Well, it is 22.5 plus 25 plus 37.5, which is 85. We knew that already because this is what we did on the last problem, right? Now, the answer then is 85 as a 1-by-1 matrix, right? So this is a matrix. In the matrix, there's one element. That element is 85.